Hi guys, in this video we are going to assemble the Robotic Arm 7, and at the end of the video we are going to carry a Lego Gong droid with it. You can access all of the project files and codes from the link in the description. But before we get started, this video features a custom power supply setup. Please proceed at your own risk. I am not responsible for any damage to your components, your board or yourself. Work carefully and stay safe. Now, let's get to the build. These are the parts we need. You can get all of the 3D printed parts from the link in the description. Let's start with base rotation piece. Attach servo head to the piece as I show, and fix it to the position with the screws that came with the servo. And do the same thing with the lower arm piece. Attach the elbow servo as I show in here. Be careful about the rotation of the piece and servo. And secure it to its position with a pair of 2x10 screws. Next piece is gripper upper arm. Attach servo head to its position and attach gripper servo as I'm showing here. Secure it with 2x10 screws. Next one is gripper piece. Attach servo head to the position and secure it with screws. And final part is the base piece. This opening here is facing toward to the back of the arm. We will pay attention to this while montaging the whole arm. Place the base servo as I'm showing in here and secure it with 2x10 screws. And next step is to montage the whole arm. While assembling the whole arm, you must run the test sketch on the Arduino. Enter character B to the serial monitor to test the base servo and press enter. After that, connect the base servo to indicated pin on screen. It will set the base servo angle to 90 degrees. Now we can montage the base rotation piece to the base part. Place the base rotation parts as I'm showing in here. Now you can enter different angle values to test it. It should move like this. If everything seems okay, secure it to its position with little screw that came with your servo. Now you can attach shoulder servo to its position. Next, enter the character S for shoulder servo test and connect it to the Arduino. It will set its position to 90 degrees. Let's montage lower arm piece. Place it at servo's 90 degree position, as I'm showing here. Enter different angle values to test its range of motion. It has to move similar to this. After that, secure it to the position with a screw. Let's montage upper arm piece. Enter character E for elbow servo test and connect it to the Arduino. After that, place the upper arm piece at servo's 90 degree angle rotation. I am intentionally placing it at slightly wrong rotation to to show you something important about calibration later. You shouldn't do that. Or do it if you want. Let's test it with different angle values and secure it to its position. And finally, let's test the gripper servo and montage the gripper piece. After entering character G, connect the gripper servo to the Arduino. Attach the gripper piece and test it. I am adjusting it so that it slightly hits the upper arm piece. We will fix this in the calibration phase. Fix it to the position and we are done. Get a rubber band and attach it to the base rotation notch and one of the lower arm notches. Use 2x10 screws to secure it. And one for the cable management. Congratulations, you have successfully completed the assembly. Next step is to connect all of the servos to the Arduino boards. Get a breadboard and unplug the Arduino. Connect positive leads of the servos to the positive rail of the breadboard using jumper wires, and negative leads to the negative rail. Connect every servo to its corresponding digital pin. You can find all of the information about the connections in the link in the description. For this robotic arm, we need an external power supply. While the Arduino has a 5V pin, it cannot handle the current draw of 4 SG90 servos at once. To solve this, I have modified a standard USB cable by stripping one end. The red wire is our positive 5V line, and the black wire is our ground. I'm using a USB-A to USB-C converter to plug this to a 5V 3A Samsung adapter. Before you try this, a quick warning. When you strip cables, always ensure your exposed wires don't touch each other. To prevent short circuits, consider using electrical tape for insulation. I highly recommend using a high-quality original adapter like this Samsung one. Cheap knockoff chargers often lack short circuit protection and can provide dirty power that might fry your Arduino, or even pose a fire risk. After that, connect the red wire to the positive rail and black wire to the negative rail of your breadboard. And you're done. Wait, you're not done. At this point I realized while editing that I missed showing a crucial step. The common ground. You must create a common ground in circuits that uses an external power supply. So I should have been connect the negative rail of the breadboard to the ground pin of the Arduino to make a common ground. Strangely, even though I forget to make a common ground in the video, the arm moves without any problem. That can happen if your devices are sharing a ground through a computer or power strip, but you should never rely on that. Without a dedicated common ground, you can permanently damage your boards or components. Now, let's get back to the video. Finally, we can upload the main sketch to the Arduino boards. First, connect the board to the computer and upload the sketch. You will see an initialization prompt and enter -R command message if this is the first run. Type -R to the serial monitor and press enter. You will see a message that says all calibration values reset and saved. Take a deep breath and plug the adapter. The arm will move immediately to its idle position. Perfect. Now you can make a quick test with moving the arm up, down, left, right, back and forth using basic movement commands. You can access all commands list in the link in the description. Next step, I'm setting up a gripper close angle and a gripper open angle. For close gripper, pick up a value so that the gripper piece do not touch the upper arm piece. Use gripper movement command to find good close and open gripper values. Here I am moving the gripper to 60 degrees and decide to set that value as gripper open angle value. After that, I'm using GO and GC commands to open and close the gripper. These values and calibration values will be saved to Arduino's EEPROM memory. so you don't have to make same adjustments every time you use the arm. When you type O and press enter, the arm moves to its idle position, so that every joint moves to exactly at its 90-degree position. But as you can see, the upper arm joint isn't pointing the right direction. It's a bit off due to a montage error, which means we need to calibrate the arm. For calibration, I'm using basic movement commands and trying to align the arm so that every joint points 90-degree angle as close as possible. Here I am checking from different angles. After that, I'm typing -C for calibration and pressing enter. And we will see the prompt calibrated and saved. And this time when you type O and press enter, the arm should move to a perfect 90-degree idle position. If you think that joint directions aren't correct after calibration, you can calibrate it again with the same process. Finally, the arm is ready for moving objects. Here I am programming the arm using waypoint list commands to carry a Lego Gong droid. You can access all of these codes from the link in the description. I am typing +M commands and hit enter, and the arm starts to move on the waypoints I entered. Nah, the first time isn't that good. +M and hit enter, and nice, we have successfully carried the Lego Gong droid. All of the efforts, countless hours of working and coding, finally worth it. Okay, that's it for this video, guys. If you find this video helpful, give it a thumbs up and don't forget to subscribe. Next time I can show you how to control this arm using Unity game engine. See you next time. Bye bye.